This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Let's practice multiplying two matrices. Here's our first example. This first matrix is 2 by 2, and this second matrix is also 2 by 2. What will the product matrix look like? Sometimes it's easier to visualize the matrix multiplication if we put the first matrix to the left of our product and our second matrix up above the product. Arranging it this way reminds us that the product will have the same number of rows as the first matrix and the same number of columns as the second matrix. So this shows us that our product will also be a 2 by 2 matrix with 2 rows and 2 columns. Let's spread out this product matrix to give ourselves space for calculations. Here are the corresponding rows and columns we'll work with for each entry. In our first entry, we'll multiply each pair of entries from row 1 of the first matrix and column 1 of the second matrix, and then add the products, like this. 3 times 1 plus 2 times 4. Great! Let's go to this entry, which will use row 1 of matrix 1 and column 2 of matrix 2, like this. 3 times 5 plus 2 times 2. Now we are moving to the entry in the second row, first column. 0 times 1 plus 6 times 4. Our last entry is in the second row, second column. 0 times 5 plus 6 times 2. Now let's simplify the expression in each entry of the product matrix. 3 times 1 plus 2 times 4 is 3 plus 8, or 11. 3 times 5 plus 2 times 2 is 15 plus 4, or 19. Down here we get 24 and 12. Great work! Let's try another example. This time we have a 1 by 2 matrix times a 2 by 1 matrix. The middle numbers match, meaning the number of columns in our first matrix is the same as the number of rows in our second matrix. So these matrices can be multiplied. If the columns of the first and rows of the second don't match, like if we had a 2 by 3 matrix times a 1 by 2 matrix, then the matrices can't be multiplied at all. In cases where you can multiply the matrices, the resulting matrix will have the dimensions of the two outside numbers. So this product will be a 1 by 1 matrix. Let's stack our matrices and multiply. We have 3 times 1 plus 2 times 4. This is equal to 11, and that's the only entry in our 1 by 1 product matrix. Great work! Let's see if we could switch the order of the matrices and multiply that way. Now it's a 2 by 1 matrix times a 1 by 2 matrix. The middle numbers still match, so this will work. But this time the product matrix will be 2 by 2. Let's stack our matrices like this and multiply. Our first entry is 1 times 3, then we have 1 times 2, 4 times 3, and finally 4 times 2. Simplifying, we get this matrix. Great work! Comparing this with our first product helps us see that matrix multiplication is not commutative, meaning the order that you multiply matters. Let's try one more example together. Here we have a 3 by 4 matrix times a 4 by 2 matrix. The middle dimensions match, so we can see that this multiplication is possible, and the product will be a 3 by 2 matrix, which we see here. This time, some of the values are already filled in. Let's stack our factors and fill in the missing entries in the product matrix. We'll spread this out to give us some space to do calculations. Our first missing entry is in row 1, column 2 of the product. So it will be equal to 2 times 0 plus negative 3 times 0 plus 3 times 2 plus 0 times 1. This is equal to 6. The next missing entry is in row 2, column 1. We get negative 1 times 3 plus negative 3 times 3 plus 3 times 3 plus negative 2 times 2. which is -7. Our final missing entry is in row 3, column 1. -3 times 3 plus 0 times 3 plus -2 times 3 plus 2 times 2 is equal to -11. Great work on these examples! You're ready to practice multiplying two matrices on your own.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.